Hi, I'm Bob Radocy with Fill Hour TRS, and I'd like to give you a user's perspective between voluntary opening devices and voluntary closing devices. There's some discussion over the years as to whether you could use both of these devices on a bilateral amputee. Well, maybe I'll impress you today and show you that it's possible. Let's start with some of these differences, and I'm going to give you a biased perspective because I used the split hook originally, and I got dissatisfied with it after about 5 years. And it was one of the reasons I designed voluntary closing grip prehensors. So I'm going to be a little bit biased in my discussion, but from a user's perspective, I'm going to try to give you a straightforward and honest reaction or explanation of how these devices work. They both work in the same way in regards to the body motions that you need or you use to operate it. These are all cable-operated devices. So glenohumeral flexion, extension of your arm, creates excursion, pulls on the cable. In both cases. In one case, it pulls the device open. In the other case, it pulls the device closed. You also have scapular abduction, whether it be unilateral or bilateral scapular abduction. That creates, again, excursion and tension in the cable, either opening or closing the device. Finally, because these are body powered, you need to, in my mind, it's very important to take advantage of all the various joints that you have available to create energy. So although we can use glenohumeral flexion and scapular abduction, we don't want to ignore elbow flexion. So if the device is properly cabled with a good crossbar strap that allows you to capture energy at the elbow, then with a voluntary closing device, just with elbow flexion or forearm flexion or abduction, adduction of the humerus, I can open and close this hook. And the same with a prehensor, with just, even though more efficient, just elbow flexion or adduction at the humerus. Okay, let's talk about the split hook. Been around for a long time. It's 1950s technology. It's simple, reliable. Split hooks come in a wide variety of shapes and materials. This is a lighter weight aluminum hook. This is a very heavy duty farmer's hook. Number 7 style hook used for very rural ranching work, things like that. They have different attributes and different shapes, but they still operate all the same way. They all operate with a voluntary opening control. They have a narrow grasping surface, so they're very good for picking up a small diameter object. You can pick up fine things with them without a great deal of problem. That's where their enhanced value is. They get their strength and power from elastic bands or springs that are mounted around here. So every time you open them, you're overcoming whatever load that is. Now that's one of the downsides to a split hook, is that every time you open it, you have to overcome its maximum closing force. So it's not that efficient. Compared to a 90+% efficiency prehensor, these are far less efficient in that regard. They're good devices. There have been literally tens of thousands of them used throughout history, and they serve a lot of people, but they have limitations to their function. The other thing is that the split hook works in what I would say has inversely proportional biofeedback. So when I grasp on and pick something up, if I was to hold on to this, it holds on by itself. It's like having a passive vice on the end of your arm, which can be convenient, but I can't tell, I can't feel anymore what's going on with that grasping force. Why is that a limit? Well, if I was to pick up a delicate object, I would have to hold back and restrain myself to prevent that object from being crushed. When I'm holding something, I completely lose the feedback loop. I have no idea how much pressure I'm applying to that. So it's kind of an inversely proportional relationship. That's exactly opposite to the way a voluntary closing device works, and it's exactly opposite to the way your hand works. When you create prehension, you output muscle force. The harder you grasp, the more resistance that you get. Split hook works exactly opposite to that. So let's talk about the prehensor. Voluntary closing, all of the same motions to operate, but the voluntary closing prehensor or a voluntary closing device in general, what does it give you? It gives you proportional grasp. First of all, it's very easy to close. It's very efficient, far more efficient than a split hook. Many people get confused when they think that they're used to using a split hook technology, and they think, well, it must be as hard to operate a voluntary closing device as a voluntary opening. It's completely wrong. It's just not accurate at all. Voluntary closing devices take very little energy to operate. About 3 pounds of energy to close. Works much like a bicycle brake, a hand brake on a bicycle. You squeeze on the bike brake handle, lever and you get more force at the brake on your calipers. The harder you squeeze the lever, the more force you get, and you can feel that resistance in the lever. Well, where do I get? If I'm grasping onto an object, I'm physically creating, this is like an active pair of pliers on the end of my arm as opposed to a passive vise. Active pliers, passive vise. This holds on, I have to hold on with this. But I have a tremendous amount of power with this. All the power that I can generate through the cable and the harness, I can put into this device. I can get over 100 pounds of force on the inner areas of this device, easily generate 15, 20, 30 pounds on the tip, upwards of 50 or 60 pounds in the center. So it gives me a greater range and a progressive range of gripping force. The hook just can't give you that. If I was to try to get 100 pounds of hook force on this prehension on this hook, I probably couldn't open it up. A grip prehensor was the device that allowed me to actually win the gold medal in Cyclothon. This device, a person like myself equipped with this device, was able to outcompete every electric, myoelectric, hybrid prosthesis in the world, the best in the world. With a body-powered voluntary closing device, there wasn't a split hook to be seen in the competition. Why? Because it just doesn't give you the same level of function that was required to do that competition, which was basically a variety of day-to-day type activities. So I think it's important to emphasize that this device beat out the best of all electric hands in the world, won a world competition, and the split hook wasn't even in the competition at all. Other features that voluntary closing devices sometimes have, this one in particular, it has a pass-through. You can hold on with objects like that, utensils and pens. The split hook has a little bit different feature. Many of the split hooks have this kind of clamping force in there, so you can hold on. But the primary thing about split hooks and voluntary closing is the way they operate, of course, and what they give you. This gives you limited gripping force, unlimited gripping force. This gives you ease of use, and you don't have to pay attention to holding. You have to pay attention to holding here. We supersede that by putting on objects like a Sherlock system, where you can engage and hold on to things. That's another story. Sherlock, voluntary closing, but Sherlock systems also work with voluntary opening. So with a voluntary opening hook, one of the features, as I said, is if you will crush things, if you allow it to relax. So with the Sherlock system, I can literally pull this hook open and I've locked it open. That's a big advantage. I can use it for 2-point hold down purposes. I can use it for 2-point or 3-point support purposes if I'm carrying something. The other thing it allows me to do is to grasp onto a delicate object, adjust to whatever prehension I want, and lock it in place. So a Sherlock should be considered with any kind of body-powered device. It enhances the function and optimum use of a split hook, and it obviously optimizes the function and use of a voluntary closing prehensor as well. I'd like to demonstrate a few features or functions that really show you a difference between voluntary opening and voluntary closing. First of all, just spontaneous reaching and grasping. With a split hook, I've got to open and close. You can see the difference in the speed. I simply reach and grasp. I've got to open and close that way. So there's a little delay in function. Again, the split hook is holding on without any effort. I'm having to put a little bit of effort in to hold this ball. It's pretty difficult to do something like this with a split hook. I'll try it, but it just doesn't follow natural pathways of reaching and grasping. Whereas the split hook, or whereas the prehensor can reach and grasp, and I can grab things spontaneously. To do that with a split hook is just very, very difficult because the biomechanics don't work the same. With voluntary closing, the biomechanics are in harmony with the way your body naturally reacts. And with a split hook, they're exactly in reverse.